check. Yeah. So welcome to the session, and this is the final session of our live discussion for signal estimation for MIMO OFDM wireless communications. And so this will be basically MMSE estimation for OFDM and channel equalization. So we'll see the numericals related to that. So the first question is, channel equalization refers to what? So we have seen in our previous lectures when we discussed channel equalization. So we use channel equalization to remove the effect of ISI, right? So channel equalization we could do by two ways. One was the time equalization, another was in the frequency domain. So the time-based equalization was called the zero forcing, and in the frequency domain we did the OFDM, right? So channel equalization is used for removing the effect of ISI. So go ahead, question 2. So we are given that we have an ISI channel. So we are given that yk is 3 by 2 xk minus half xk minus 1 plus v of k, and we are given it is a two-tap channel equalizer, and we use symbols yk and yk plus 1 to detect xk, and we are given that the PD is 9 dB. So and we need to find the effective channel matrix. All right, so we'll write for yk plus 1 because they have used k plus 1 and yk to detect xk. So this will be 3 by 2 times xk plus 1 minus half times xk plus pk plus 1. So if you write this in a metric form, you have yk plus 1 and yk, and what will you have here? So 3 by 2 minus half 0 0 3 by 2 and minus half, right? And we have xk plus 1 xk, and we have pk plus 1 pk. So this is what we have. So this is my effective channel matrix H. So this answer is A. Any questions? Okay. So next question. This is a build up to the previous question. So yes, again yk is given, R is 2-tap channel equalizer, and PD is given 9 dB, sigma square is minus 3 dB. We need to find the LMMSE equalizer C for the estimation. So let's solve this. So first we are given PD is 9 dB. So this comes out to be 8. Okay, so if you do 10 to the power 9 by 10, as we you can use calculator for this, and sigma square is minus 3 dB. So this comes out to be half. Okay, so you can again use the calculator for this, right? And C, which we have been asked, that is the equalizer vector. So this is given by PD H transpose plus sigma square I inverse PD H. And since we need to find out xk, right? So xk is basically 0 1 0. So if you write in the one vector notation, right? So this is what we have, and we need to solve this. Okay, so this is the equalizer vector. So let's solve this. So first we'll do HH transpose. So what is HH transpose? So you have 3 by 2 minus half 0 0 3 by 2 minus half 3 by 2 minus half 0 0 3 by 2 minus half. And if we solve this, we have 10 by 4 minus 3 by 4 minus 3 by 4, 10 by 4. Okay, so this is H transpose. And then if we substitute everything in this, so C will be so PD is 8. Okay, 8 times 10 by 4 minus 3 by 4 minus 3 by 4 10 by 4 plus sigma square I. So sigma square is half. So you have half 0 0 half, and you need to take the inverse of this, right? And 8 times yeah PD H and this, right? So 8 times. So this will come out to be actually minus half 3 by 2 because we are focused on xk. So this is the middle column. Okay, 8 times minus half. So now we need to solve this. So let's solve this. Okay, so we will get so this is 20 minus 6 minus 6 20 plus half 0 0 half inverse, and this is 8 times minus half and 3 by 2. And so this comes out to be 1 by 1537 82 24 24 82 times 8 times minus half 3 by 2, and this will finally come out to be minus 40 1537 8. So this is basically calculation intensive problem. So you just need to remember the formula and fit in the values. Okay, any doubts? So this option is, let me see, this is B, right? Yeah, this is B. Okay, we'll move ahead. Question 4. So same question, and we are asked what is the MSE, mean squared error, for the equalizer vector which we computed. So the MSE is basically given by PD minus PD 1 vector HC. Okay, so this is the expression for MSE. So PD was 8, if you remember. So 9 dB comes out to be 8 as we did in the previous slide, and 8 times. So what do we have here? So we have this is 0 1 0. Okay, and H transpose. So just a minute. Yeah, H transpose will be 3 by 2 minus half 0 0 3 by 2 minus half, and we have C, which is minus 40 over 1537 888 over 1537. So is the dimensions correct? Let's check. So 1 cross 3, and this is yeah 3 cross 2. Okay, so if you see, this is 8 minus 8 minus half 3 by 2 times minus 40 over 1537 888 over 1537, and this comes out to be 1480 upon 1537. So if you see, this is 1 cross 2 and this is 2 cross 1, so it ultimately becomes a scalar, right? So the MSE is a scalar quantity. So this is one, which option this is? This is option C. Any doubts? Okay. Right. So this is a OFDM question. We are given an OFDM system. N is 4 and L is 2. So two channel types are there, H0 and H1. And it is given that H0 and H1 are IID Gaussian with zero mean, and variance of each channel is given as 1 by 2. And so LMMSE channel estimation is employed. So we are given the uh, frequency domain symbols which are loaded on the subcarriers X0, X1, X2, X3. And in the time domain, we are given what has been received. So this is small y 0, 1, 2, 3. And cyclic prefix is 1. Okay, so the coefficients HL on the Lth subcarrier. Okay, so this is what we have been asked. So we know that. Okay, so the channel coefficients on the Lth subcarrier. Okay, so they are first zero mean, and then they are Gaussian distributed. Okay, and what is the variance? Okay, so variance is L times sigma h square. Okay, so what is L? So it is 2. So this happens actually in OFDM. The number of channel taps influences the variance. Okay, so it is 2 times 1 by 2, which is 1 in this case. So here it is said variance is 1 by 2. Here it is said variance is 2, variance is 2, right? So our variance is 1. So that is why it is none of the above. So be cautious in such numericals. Okay. Confusion? Question 6. So again, this is a build up to the previous question, and we are asked the transmit block of symbols in the time domain. Okay, so we need to basically convert the frequency domain, that is capital XL, into the time domain, okay, which is small x of k. Okay, so this is what we need to do, and what do we do for that? So we use the IDFT. Okay, so in week 7, OFDM, right? So that I'll just quickly go through it. So xk is basically 1 by n, which is 4 in this case, right? And summation L is 0 to n minus 1. N minus 1 is 3, and x of L e to the power j 2 pi k L by n, right? So this is our expression. Okay, so for k is 0, let's first do for this. So x of 0, this will be 1 by 4, and this will be a state addition of all the frequency domain symbols. Okay, so why? Because k is 0, so the exponential term uh, e to the power j 2 pi times something over 4, and this is 1. Okay, for all the cases. So this is x1, x2 plus x3. And if we solve this, let's just do it. So what we have? Minus 2 plus 3j plus 3 minus j plus 1 plus 3j minus 3 minus 2j, and this is 1 by 4 minus 1 plus 3j. Okay, so this is my x of 0, that is the time domain symbol at the 0th subcarrier. Okay, so for k is 1, I'll just write the expression. So x2 is 1 by 4 x of 0 plus x1 e to the power j 2 pi 2 by 4 plus x2 e to the power j 2 pi 4 by 4 plus x3 e to the power j 2 pi 6 by 4. Okay, and oh, I'm sorry, this is I did for k is 2. Okay, sorry. So this comes out to be minus 1 by 4 plus 9 by 4 j. For k is 1, x1 will actually be 1 by 4 x0 plus x1 e to the power j 2 pi 1 by 4 plus x2 e to the power j 2 pi 2 by 4 plus x3 e to the power j 2 pi 3 by 4, and this comes out to be minus 1 plus 3 by 2j, right? I'll just sneak in k is 3 here. So x3 is 1 by 4 x0 plus x1 e to the power j 2 pi 3 by 4 plus x2 e to the power j 2 pi 6 by 4 plus x3 e to the power j 2 pi 9 by 4. So anyone is having any confusion in how to solve the IDFT? Just feel free to ask. This comes out to be this. So, and then they have asked cyclic prefix also. Okay, so what will happen is that we basically have x0, x1, x2, x3, right? So x3 will actually go in the initial. So this is the final transmitted block. So this answer is C. So if you see, we computed for k equal to 3, right? Minus 1 by 2 minus 3 by 2j. So this is my first block because it is the cyclic prefix block, right? And after that we have minus 1 by 4 plus 3 by 4j, which was my x0. Okay, so any doubts? No doubt. Question? So question 7. This is also built up to the previous two questions, and we need to find the received symbols across the subcarriers. So now we are given y0, y1, y2, and y3. These are in the time domain. Okay, so now we need to convert the time domain, that is y of k, into the frequency domain, that is capital Y of L, and we need to do the DFT in this case, right? So let's do that. So capital Y of L, and this is k is 0 to n minus 1, which is 3 by k e to the power minus j 2 pi kl by 4. So this is what we have, right? So let's do for L is 0. So for L is 0, it is straightforward. So it is y0 plus y1 plus y2 plus y3. So again, this is because the e to the power anything 0 is 1, right? So this will always happen for any case, IDFT or DFT. So the first term is always the simplest to calculate, right? So you just need to add up everything. So this is 3 minus 2j minus 1 plus 2j minus 1 minus j plus 2 plus 3j. Okay, and this is 3 plus 2j. For L is 1. So you have y of 1 what is this? So this is y0 plus y1 times e to the power minus j 2 pi to 1 by 4 plus y2 e to the power minus j 2 pi 2 by 4 plus y3 e to the power minus j 2 pi 3 by 4, right? For L is 2, so y2 is y0 plus y1 e to the power minus j 2 pi 2 by 4 plus y2 e to the power minus j 2 pi 4 by 4 plus y3 e to the power minus j 2 pi 6 by 4. And finally, for L is 3, we have y3, which is y0 plus y1 e to the power minus j 2 pi 3 by 4 plus y2 e to the power minus j 2 pi 6 by 4 plus y3 e to the power minus j 2 pi 9 by 4, right? So this is what we have. And what are these symbols? So it is 3 plus 2j, right? So this is y of 0. Right? Then you have 3 plus 2j again. So this is for y of 1. Then you have 1 minus 8j. This is y of 2. And 5 minus 4j. This is y of 3. Okay. So any doubt in DFT operation? Okay. So if you still have problems calculating this e to the power term, refer to week 7 and refresh your trigonometry to calculate the phase at each DFT or IDFT. Okay. Right. So, okay. So now we are asked in the same, it's a build up to the previous question, that what are the estimates h hat 0 and h hat 1, right? So this is the estimation question. So let's just do that. So h hat L. So the formula is given as discussed in lectures, L times sigma x square x conjugate L, okay, divided by L sigma h square xl square plus n sigma square, and this is times by L. Okay, so this is my formula for computing the estimate, right? So, and what are the x0? So x0 is minus 2 plus 3j. So this is given in the question, right? And x1, this is basically 3 minus j. Okay, this is also given in the question. And what is y0? So these are the things we need to calculate, right? And y0 we computed in the previous question, which was 3 plus 2j, and y of 1 is basically, it is also 3 plus 2j, right? So, okay, so let's just do it. So h hat of 0. So what is L? L is 2. Okay, so 2 times sigma h square is half x conjugate L. Okay, so this is minus 2 minus 3j. What is conjugate? So if any x is a plus jb, right? So x conjugate is a minus jb. Okay, so this is the, so the imaginary part becomes negative. So that is the meaning of conjugation. And what is y of 0? So it is 3 plus 2j, and we divide it by 2 times 1 by 2. And how to do mod xl square? So, right. So what is, again, what is mod of x? So this is under root a square plus b square. Okay. So this is if x is a plus jb, then mod of x is root a square plus b square. That's why mod of x square will be a square plus b square directly. Okay, so this will be 2 square plus 3 square plus what is n is 4 and sigma square. Okay, sigma square is minus 3 dB and minus 3 dB was half. Right, so minus 3 dB was half. Right, so this is equal to half. You can do by calculator, and if you solve this, so this 2 and a half will get cancelled out with each other, and you will be left with minus 13 j by 15. Okay, so this is h hat of 0. Similarly, h hat of 1. So what will be h hat of 1? So again, 2 into half, and this will be 3 plus j. Okay, now the cx of 1 is 3 minus j. Therefore, x conjugate of 1 becomes 3 plus j. Right, and this is 3 plus 2j divided by 2 into half, and this is 3 square plus 1 square plus 4 times half, and if you solve this, this comes out to be 7 by 12 plus 3j by 4. Right, so our answer is D. Any doubts? Any doubt in this question? No doubts? Okay. Question 9. Again, it is a build up to the previous questions which we are doing. Now we are asked what is the mean square error of the estimates. So in the previous question we computed the estimates, and in this question we have to compute the mean square error of the estimates. Okay, so what is the mean square error of the estimate? So it is given by expectation h hat L minus HL square, right? So this is the and as derived in class, it is mod XL square over n sigma square plus 1 by L sigma F square. Okay, this is what we have. So I'll just plug in the values. Okay, so that is all you need to do. Okay. So expectation h hat 0 minus h0 square, and this is basically 1 by okay, so let me just write this. So we have x0, which is minus 2 plus 3j, and x of 1 is 3 minus j. Okay, so what do we have? So we have 4 plus 9 divided by 4 into half plus 1 by 2 into half. Any doubts? Right, and this will come out to be 2 by 15. Okay. Similarly, expectation h hat 1 minus h1 squared, and this is 1 over 9 plus 1 over 4 times half plus 1 by 2 times half, and this comes out to be 1 by 6. So the answer is A. Any questions? Okay. Final question. So we need to find the LMMSE estimate. Now they have asked for the time domain samples. Okay, so the previous was for the frequency domain symbols, and this is for the time domain symbols. So now what you need to do, so you need to again use the Fourier transform. So you need to find h hat k, which is again 1 by 4 summation L is 0 to 3 h hat of L e to the power j 2 pi kl by 4. So you need to use the IDFT. Okay. So all right. And we know that h hat of 0 is, so we minus 13 by 15j. So if you remember in the 2 questions back, we computed h hat of 0 and h hat of 1, which was 7 by 12 plus 3 by 4j, right? So what do we need? So we need h hat 2 and h hat 3, right? We need to compute them also. So h hat 2. So so this is the process to find out h hat L. Okay, so you need to yeah. So you need to first use this formula of h hat L to compute each h hat L, and then you need to find the time domain small h hat L, right? So you need to then apply the IDFT. So first we need to use this expression in question 8, compute the capital H hat, and then use the IDFT. So this is going to be the procedure. So this will be 1 minus 3j, 1 minus 8j divided by 12, and this is minus 23 by 12 plus minus 11 by 12j. Okay, and h hat 3 is basically 5 minus 4j minus 3 plus 2j by 15. This is minus 7 by 15 plus 22 by 15j. Okay, so now what do we have? We have now calculated all the uh, frequency domain symbols, right? And now we need to calculate what is it in the time domain. So h hat 0. So h hat 0 is directly sum of all. Right? H hat 0 plus h hat 1 plus h hat 2 plus h hat 3. Right? So this is directly straightforward. So this is minus 9 by 20 plus 13 by 120j. Okay. Sorry, this is 1 by 4 times this. Yeah. And h hat 1 is 1 by 4. Okay. And this is summation L is 0 to 3 h hat L e to the power j pi by 2 L. So this is for case 1. Okay, this is for this case, and this is 1 by 4 minus 13 by 15j plus j times 7 by 12 plus 3 by 4j minus 23 by 12 minus 11 by 12j minus j times minus 7 by 15 plus 22 by 15j. Okay, so this is what we have, and this comes out to be 79 by 120 plus 33 by 120j. So this is what we have. So this is answer C. Okay. Any questions? Any doubts?
Sir, please show again question number 1 and 2.
1 and 2?
Yes, sir.
Just a minute. Yeah, so question 1 was very straightforward. So what is channel equalization? And it is removing the effects of ISI.
So the correct answer is the removing the effect of eyesight. Right?
Yeah. Option D.
Okay, sir. And next 2, sir.
Yeah, question 2. So we had to make the effective channel matrix. So we were given yk. Okay, we made yk plus 1. Just time shifted and write it in matrix form. Okay. It is
Only
straightforward.
H mentioned. No?
Yeah, if you read the question, the effective channel matrix H for this scenario, right?
Okay.
So,
Okay, sir. Thank you, sir.
yeah. Any other questions, clarifications to anyone? Okay, then I think that's it, right? So all the best, and for your exams, all three of you giving exams.
Yes, sir. On 30th of October,
Yes,
sir.
sir.
Yeah, okay, great, great. So if
Yes,
you
sir.
wish, this is a very good area for future research. You know, it is upcoming 5G in India. It is just coming, and 6G communications is also coming in the world. So telecommunication is good area, and this is the basic of telecommunications, right? So do give GATE examination, okay, and try to come for masters, further PhD, if you like. So
Sir,
all the best, and yeah.
sir, I want a question.
Uh-huh.
I want to ask a question, sir.
Yes.
Presently, sir, I am doing a PhD from Triple IT Kota.
Okay.
And my research area is channel characterization at 60 gigahertz by using MIMO and OFDM beamforming.
Okay.
So, sir, can you just suggest the which method or which beamforming we can use for the
So if you
best
are
channel
going
characterization?
for channel characterization, right?
Yes.
So I think channel estimation is what you are
Yes.
saying. Okay. So okay, I think we'll discuss that after this meeting. So let
Yeah.
me just
Yes.
wrap it up. Okay.
Yes.
And so what more? Yeah, and I had circulated one feedback form. So, you know, please do fill that because it is my first experience as a teaching assistant. So it will be valuable. So what I'll do is I'll just give the feedback form link in the YouTube first comment itself. So, you know, it will be easier.
Sir, this feedback form fill for the all 11 weeks or 1 week old?
So I think the system generated feedback is will go to them to the NPTEL office, and so I have not seen that form actually. So
Yes.
you can, yeah, you can give whatever feedback you like. And there is one feedback form which I had floated that is for my personal feedback. Okay, so
Okay.
you can, yeah. So that I will be giving in the first comment of the YouTube
Okay.
when I upload it. Okay, so. Right, then I'll just stop the recording. Thanks.
Thank you so much,
Thank
sir.
you.
It
Thank
was
you.
wonderful, actually. I'm from